Hello, welcome back to Auto Guide My Class, a platform where you get a real-time solution to mathematics problems. All topic in mathematics problem can be found at a group of author channel. In this video, we are going to have a walkthrough on inequality graph. So, previous video we've started inequality, where I started with a linear inequality and combined inequality in those videos. In this video, I'm concentrating on inequality graph. Inequality is a topic that is more than just getting the answer alone. It is a topic that has a lot of application. Inequality graphing is the foundation of most of the application in linear programming. In linear programming is used in optimization, in decision making of real life situation. For example, our budget need to be planned within the income. Whatever budget you have, whatever anything you want to undergo, so you need to plan. You need to plan it, make a decision. There should be limitation. The limitation that you have is your income. Your budget will range within your income, and whatever budget you have, whatever anything you want to achieve, it's within your income. That within income is what they call limit. And the best expression you can use in mathematics to model such kind of a situation is inequality. When you have two products that you want to undergo, so you can use this graphing method or linear programming, which is that we use in linear programming, to make a decision within your budget. So it is a topic that teaches us how to make a decision within your limits or limitation or your budget that you have, or the income that you have. All right. So that is why it's very important. And I want everybody that will have access to this video to follow me on this, subscribe, so that as I start from the beginning, graphing it, then until we get to the point where we get to linear programming, and you can be using it to make a decision whenever any situation or any product or production of something you want to undergo. So you can use it to maximize profit. You can use it to minimize cost of production. So that's all about optimization. So now I am starting from foundation, the graphing of linear inequality. Now, a linear inequality starts from the x and y axis. Let me come with a graph. Let's assume we work with this graph. Let's work with this graph. Now, if you look at this graph, I have two axes on this graph. The x-axis on that graph and the y-axis. So this is my x-axis and this is y-axis, as we have in our normal graph. But when we talk of linear graph, inequality graph, or linear graphing of inequality, a graphing of any equation come along with what? With a coordinate of points. The coordinate of points is very important. So let's, for example, I want you to graph x is less than 0 and less than 0, and also show s is greater than 0. So we want to use the shaded region as less than and the unshaded region as greater than. So this one will be shaded region. I will shade this region that is less than. Then I will unshaded for greater than, because the inequality has to do with region. Now, anytime I mention x and it equals to 0, before this x greater than 0, s less than 0, it has to, the demarcation must be at a point where you have s is equals to 0. The line equality sign indicate a line talk about equality. Now, if I mention s is greater than s is equal to 0, what should come to your mind is what? Y-axis. Some students have a lot of misconception when they say s is equal to 0. They will be looking at the point where you have a long axis, that line should be parallel to x-axis. No. S is equal to 0 is a vertical line, and s is equal to 0 is along any point along y-axis. So this must be my point where s is equal to 0. So y-axis is a point where s is equal to 0. S is equal to 0 here, 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 s is equal to 0. Along that y-axis, every point there, s is equal to 0. S is equal to 0 along those axes, along that y-axis. So all this along y-axis here, x is equal to 0. So the line along that point is x is equal to 0. So if I'm to draw s is equal to 0, what I will draw is what? Any line along this y-axis. Now, if I want to show the point that is s is less than 0, then what I will now do is to what? Is to shade the portion. Like I said, the shaded region, like I said here, I said the shaded region is a point where s, so I will pick the shaded region. Let's see, the shaded region is a point that the region where s is equals to. So let's, all right. Can you see? So this shaded region, there are points where our x, this region is the point where our s is less than 0. Then this unshaded region, the whole of this place, there are points where s is greater than 0. So these are region where s is greater than 0, because I said unshaded region should be s greater than 0, then shaded region should be s less than 0. And the point where s is equal to 0 is along y-axis. So this is where x is equal to 0. So x is equal to 0 along y-axis like this. This is x is equals to 0. X is equal to 0 along y-axis. But you can see that at that point, the line must be the line, if it's strictly greater than or less than any of this one, whether greater than or less than that you want to show, the line that you will use to represent that point should be a dotted line, should be broken line. So we can use broken line like this. Let's use a broken line. So we can put a broken line for that y-axis. So let's use our broken line for the y-axis. Let's start from here. And let's mark that point. Make it yellow. And we want it to be broken line. So we can use broken line for the, so the line must be a broken line. You see now, the line must be broken line for the, so you can see that I have a broken line along that part. And this part is shaded, which is s less than 0, because I said shaded region should be s less than 0. Then unshaded region should be s greater than 0. This unshaded region. This is one of the graph. Let's go to the second part of the graph. Let's have a region like this. So want us to draw a graph where y is greater than 0 or less than 0, and also y, the same y is greater than or equals to 0. Is greater than or equals to 0. So let's do this graphing of this point, of the point here, where y is less than 0 and y is greater than 0. All right. Then at this point, we have, all right, let's insert our graph here. So we are going to work with this graph also. But now, on this graph, we have y along y, and y is less than or equal to 0. This y is greater than or equal to 0. Anytime we talk of y is equal to something, what should come to your mind? The line should be horizontal. The line will always be horizontal. So since y is equal to what? 0, in between this region, the only value that you draw where y, it should be what? Y is equal to 0. Y is equal to 0. Then you have to first of all draw where your y is equal to 0. A y is equal to 0 along x-axis. Along x-axis. Look at it. Every point along this x-axis, y is equal to 0. Y is equal to 0. Any point along this x-axis. You see, any point along this x-axis, y is equal to 0. 0 is common on this point. Now, if I'm to draw y is equal to 0 now, I will put a line along the y-axis. So let me just pick a line along this y-axis. This is the point. Then let me make it thick. All right. So let me increase the thickness. You see? So this is the point where y is equal to 0. Right? Y is equal to 0 here. Now, we have two sides of this line, either up every region here or down. Now, here, like I did in the first one, I'm going to use here, I will use I'm use shaded region for y is less than 0. Then unshaded region, unshaded, okay, unshaded region for y is greater than or equal to 0. All right, that's what I will do. For y is less than or equal to 0, I'm going to use shaded region. I'm going to shade the region. So let's shade the region. So to shade the region, let me do it. All right. That line should be thick. Line. Then let's make it black. And it's going to be thick line because it's greater than or equals to. So this line here, which is where y is equal to 0. Y is equal to 0 here. Y is equal to 0. Y is greater than or equal to 0 here. But y is less than or equal to 0. The shaded part is y is less than or equal to 0. But here, y is equal to 0 along the line. This line, this thick line, is y is equal to 0. Then unshaded part here is y greater than or equal to 0. Then this shaded part is y is less than or equal to 0. Every part here, their y is less than or equal to 0. So whatever any point I have here now, look at it. Even if I put something here, if I want to put a coordinate here now, so the coordinate is going to be here at this point is going to be minus 12, comma minus 4. You can see that at this point y is less than or equal to 0. It's less than or equal to 0 is significant because minus 4 is less than 0. So any point you pick here, the y value coordinate will be less than or equal to less than 0. So this is how we draw a graph along the y-axis. So let's also go to the next Let's, for example, we want to draw a show the region with this. Let's say X, show the region X, region where X is greater than, let's say X is greater than or equals to 4. Also, Y is less than, so show Y is less than, strictly less than, let's say minus 5 region here, and put it on the graph. So let's graph it out. Let's show the region here. Sometime the region so let's have our graph. This is our graph, and in this graph I want to show the region. So I have my y-axis and this is x-axis. So that one is constant, that one is always there. So we have here, this is our x-axis and this is our y-axis. And if I want to draw a line where s is greater than 4, greater than or equal to 4, because it's greater than or equal, so whatever line I'm going to choose now is going to be thick line. So I will go to pick my line, then I will go to where s is equals to 4. S is equals to 4 here, this is 4. So I will put the line there. This is where s is equals to 4. And the line must be thick line. So the thick line, the line has to be thick. So, and thick and continuous line. Thick, continuous line, can you see? So it's thick and continuous because of the equality sign. That means that point, that line, along the line is part of the solution. You know, when you have equality, it means something is greater than 4, but it's also equals to 4. That's the meaning of this interpretation of this. That means this line where x4 is part of the range. You see that? Now, and I said shaded region is our solution. Shaded region is required. Let me write it. So we need shaded region. Shaded region are required. Shaded region are required for the two graphs, this one and this one. Shaded region are required. So that means the part that will be the solution should be shaded. This one is always part of the question. So part of the question, when you look at the question, if it is WAEC or whatever exam it, so if it is not part of the question, you have to indicate it, that you are using the shaded region as your solution, as your required solution. Or you are using unshaded region as your required solution. You have to indicate it. But most of the time, it's always part of the question that you should use the shaded region because they want the answer to be uniform. So now the shaded region are required. If the shaded region are required, so, and I need a part that is greater than 4. Greater than 4 mean anything along this, above this. Look at it from here. This is 6, 8, 5, 6, 8, 9, 10. They are all greater than 4. That means the part I will shade now is that part. So let's see how we shade that part. It's not the all right. You see, sorry for the imperfection is so this region, this at region that is what this shaded region, they are the region that is greater than or equals to 0. You see all these parts, they are greater than or equals to 0. So I can write on it that this part s is greater than or equals to 0. So we see that all this region should be shaded also. All this part should still be part of the answer up till what this region. They are still shaded region. They are part of the solution. Right, so they are shaded region. All these parts, they are shaded. So they are part of this, all this, they are shaded. You see, all this region, they are our solution. All right, they are part of, you see, they are part of the solution. So this, now also, we can also get the region that is y is less than or equals to minus 5. Y is less than or equals to minus 5. Which part that is less than or equals to minus 5? So what I will do is this. I will go to pick my line. let's pick a line. Then go to where, so y is -5 between -4 and -6. So here, so let me put it here, in between here, put a line. And anytime we talk of y, I say y is always a horizontal line to the what? It's always parallel to x-axis. Anything y to indicate y. Anything on this line now, every point here on this line, along this line, y is always 5 across the line. So that's how that one work. Let me make it thicker. So because it is less than, strictly less than, it's going to be broken line. So that's one of the things you also need to know. So the line need to be broken line. See now. So the line is totally going to be broken line. It means 5 is not part of the answer. 5 is not part of the answer. So that's why it's broken, to show that 5 is not part of the answer. You see, we use a broken line for strictly less than or greater than, and we use a thick line for greater than or equals to, less than or equals to, right? When you see equality sign, we use thick line, like the way we use thick line here. Or here, because it's strictly less than or equal to, we use broken line. So please take note of that. It's very important. So then you write on it. That this line is what? Y is less than equals to 0. Less than equals to -5. We're talking about -5. Now, but where is to be shaded? Above or below? Y is less. This part should be less. This part is less than. So where to be shaded should be the part that is less. So let's go and pick where to be shaded. So let's assume we are picking this region. Don't mind me. Okay. Sorry, it may not be perfect, but let's just see it like that. I want the line to show. So let's do some transparency. All right. So the line is transparent, so that we can see other line. So here, you can choose okay. Can you fill it with another color? Can fill it with another color to fill it with another color different from what we had before, and then let me use that yellow to complete the parts. You see, let's complete the part. All right, all this region, they are the required region. So now, if we've shown all this part that is yellow, filled with yellow, they are what? So they are less than, this part are less than, y is less than equals to -5. This yellow part, they are less than equals to -5. Sorry, here you made a mistake here. This one is this one is greater than or equals to 4. This is 4. All right. Now, but we've shown the part that is greater than or equals to 4. We show the part that is less than or equals to 4. But there's a region where there's intersection of the two color. The region where there's the intersection of the two color is the main region, is the required region. Look at this. This region where we have the two intersection of the two color. Look at it. This region, we have the intersection of the two color. We have yellow color and the blue color is the actual region that is required. This is the required region. That is, if you are doing optimization, this is the required region. This is the required solution. Required solution. And you can say, name it as what? R. So you just put your R, required region. So this point here, this point, they are the required region. That's what? That should be the emphasis. So this one is one color, this one color, this region they have one color, but this region they are intersection of what? The two color. This intersection is where we said shaded region are required. That means this is where the two color intersected. So where the two color intersected is what? Is the required region. So that's for that. Now let's go to the next question. let's, for example, I said the graph of draw the graph of x is less than 3 or less than 2, and y is less than y is less than or equals to y is less than or equals to 6, or let me use 4 because I want it to fall within the, all right, and okay, and another one, let's say x s is greater than or equals to let's say minus 4, s is greater than or equals to minus 4. Let me turn this one to y is greater than or equals to 4. All right, let's have this type of question and see which region will be the required solution. So we have to find this draw. Let me use capital letter here. So in this, let's put our graph. So let's have this graph. Let's in this graph, I have x-axis and y-axis on this graph. This is my x-axis, and this is my y-axis. It's my y-axis. The first thing to draw is s is less than 2. X is less than 2. I will go to where I have 2. This is 2. This is 2. So pick a line. Let's pick a line along that region. So let me put where s is equals to 2. And remember, s is strictly less than 2. If s is strictly less than 2, the line is going to be broken line. So let's change it to broken line. So let's use this one. That means it's going to be broken line. X, anything x is going to be vertical line that will be parallel to y-axis. S is less than 2. And remember, please, before we do, part of our question is that shaded region is required. Shaded region, or let me use unshaded region now. I can use unshaded region. So let me do it this way. Say unshaded region is required. Okay, you can also use that. Say unshaded region is required. Let's just not concentrate on the shaded region all the time. So let's assume unshaded region is required. Unshaded region is required solution. It's required solution. This one will be part of the question. That if it's not part of the question, please, you have to write it, the part you require for your solution. So if unshaded region is required for the solution, if s is less than 2, if this part, the whole part of this one is less than 2, I will not shade that part that is less than 2, which is my required solution. I'm going to shade the region that is not required. Do you understand? That's just the idea. If it is unshaded region is required solution. Unlike the first one where I said shaded region is required solution, I considered anywhere that is the solution, I shade it off. I shade it as my solution. So, but here is unshaded region. That means the part that is my required solution should not be shaded. So this is my required solution here, which is anything less than 2. Less than 2 is my required solution. I mean, this front side here. Anything greater than 2 is unshaded, should be shaded. That means it's not a solution. So I'm going to shade it off. So let's see how we shade it off. So let's go this way. Sorry. Oh. All right. Let's just see. It's not perfect, but at least. So the part now is not required. Let me use other color to show other part. They are not required. I don't want this. All right. So this region, they are not part of the. All right. Okay. So let me do transparent so that the answer way this region should be transparent region. All right. Yes. So you can see that. Let's use our color. Use color fill. Use color. Okay. All right. This unwanted. This is part that we need. Then let's draw the second one. Y is greater than or equal to 4. So I will pick my line. Y is greater than or equal to 4. Is 4. So put a line along that 4. Sorry, draw that line. Okay. That line must be exactly along 4. I think. Okay, let's make it thicker a little bit. Okay, and why is it thick? A thick line because it's greater than or equals to. It's not going to be broken line. Greater than or equals to, and it's along 4. And like I said, we need a part that is greater than 4. A part that is greater than 4 is above the line. Above that line, everything above that line is greater than 4. Everything below the line is less than 4. Anything below the line, now we're going to shade it off because we don't need it. So because we need unshaded region. That means the part that we need as our answer should not be shaded. So I'm going to shade the part that is what? That is not our answer. So let's see how we shade that region off. Let's see. Okay, so let's see this. And since it must be transparent, let's use transparent so that we can see the part, we can see all other line. So this part, remember, we need the unshaded region. The unshaded region, let me write on it. This part that we shaded, so we can use another color. Let's use another color for this, so that at least color. Let's use another color for this part. All right, we use another color for this part. So this part is the part here. The region here is the part that is y is less than equals to 4. But the part that is greater than 4 is above, right? So this part here is the part where x is greater than 2. But we need the part that is less than 2. The part that is less than 2 is at this side. The part that is greater than 4 is. So you can see that there is a portion that is unshaded, which is our solution. Now, then it remains 1. S is greater than equals to minus 4. Where S is greater than or equals to minus 4. Now we go to minus 4. X is going to be vertical line. So we pick our line. So let's pick a line and go to where we have minus 4. This is minus 4. Then let me put line along that line. So this is the line. And is greater than or equals to is going to be thick line. So let's make it thick. Let's make it thick at least. Okay. All right. That line, this is the line. And we need the part that is greater than that minus 4. The part that is greater than minus 4 is here along this side of the line. So the part that is less than is this side. So we don't need the part that is less than. You see that I'm cutting some things up. I'm just cutting it off, cutting some part off. So that until you get a region that is unshaded. So along the line here, we can write, all right, please, we are on this. Along the line, can pick our pen and write along the line. So this is part that is S is greater than or equals to -4. Right. Now this is S greater than. So S is here is S is this line is S is less than 4. S is less than S is less than 2. Then here is Y is greater than equals to 4. All right, I have 3 of them. Now the part that's going to be shaded now should be here. So I'm going to shade this part off. So which part will be shaded? Is this part. So let's go. Okay, let's go. Okay, let's go. Right. So this part is going to be shaded. So let me see now, and it's going to be shaded because I don't need that part because it's on unwanted part. So if you like, you can use another color for that, just to do some variation in. Let's see. Okay, so let's just this. Now with this, what you find here is that there is a portion here, this region here that is unshaded. See, this region here that's unshaded is our required solution. This is our required solution, and the region what will be, you see that it's thick line here, and it's what is dotted line here. This type of line, they are very essential in this what they mark. It means this line is not part of the solution, but here is part of the solution, here is part of the solution. So now the region here, the required region now should be this one at the center here. So this is the required region. The required region now is this place. So I can label it as what? R, which is this portion, this here, and here, and here. So this thick line, then shaded line. So this region now is the required region for our solution. I hope this is also very clear. Now, what of if something is a line of this form? Draw the graph of this unshaded region is required. This look like the equation of a line. Equation of a line, we are going to get, we use intercept method to get our region to be shaded. So we have equation of a line here. So whenever there are two ways of doing this, when it is equation of a line, y is equal to, I can write it in form of a line. Anytime you write it in equation of a line, whatever you have, let's say you take this one across the other side, if what you have here is greater, it means you're going to shade above. If you have here is less than, it means you're going to shade below. So what I mean is that if you are using equation of a line, if you write it in the form of, if you can write it in form of y is equals to mx plus c, right? So if you can write it in this form, whatever is here will depend on where to be shaded. For example, if I write it like y is greater than, since I have it greater than, then every other line passing across that one will be, this is going to be 5x, then this one is going to be minus 5, right? So what I have here is greater. It means, since what I have here is greater, then how am I going to write how plot this graph? This is how to plot the graph. To plot the graph, you come here, you put your graph. Let's, for example, this is our graph. In this graph, I have y greater than or equal to 1, and I've written it in standard form of this equation of a line, y greater than 5x minus 5. So this method is very simple. We can use this method. It's also very simple. And we also have another method. If it's that one, maybe I will also explain that one to see whichever one that's convenient. You take anyone that's convenient. So since I've written it in form of this equation of a line, which is y is equals to ms plus c in standard form, you see that my intercept here, the 5 here is my gradient. So here I will pick what is my gradient there. You see that my gradient m is 5, is plus 5, and my intercept, y-intercept is equals to minus 5. So with the help of these two, let's say minus 5 over 1, right? Minus 5 over 1. So now let's go with this. So minus 5 over 1, because we are going to use for the intercept, the slope, sorry, the intercept is minus 5. So let me not just put it. So let me cancel this. The intercept is minus 5 directly. It is not, okay. The intercept is minus 5. And the gradient is 5 over 1. All right. 5 over 1 means here, for the gradient, we are using rise and run. Rise, it means rise vertical. The rise is for the vertical. Let's say rise is go this way, up and down. If it is positive, for negative, down. Then run is for along horizontal. This one is for negative, this one is for positive. Right? If it's going to be positive to go this way, if it's going to be negative to go this way. For the rise, if it's going to be positive to go up, it's going to be negative to go down. That's what you use here. And it is very easy to use to draw this one after you have written it in intercept method. Then for this one, I will start with what? By indicating where is my what? Where is my intercept? My intercept is at minus 5. So minus 5 is here. So I'm going to mark that point. This is minus 5. I will mark the point of minus 5. Then also now, sorry, don't know why. Minus 5 is that point. Okay. Sorry. If that place is minus 5, then we have, from that minus 5, we have 5 rise. The rise from the minus 5, you rise up. Because rise is, the 5 is going to be positive over another positive. Rise, that means we go up. From minus 5 here, I will count 5 above. 5 above from minus 5. So from minus 5, this is 1, 3, 5. I'm going to be here. Then run. Run is also positive. So I will move here. So this is 1. So I'm going to mark this point, minus 5, here and here. That's where my line will pass through. Here and here. That's where my line is. That's 5 and above, 5 to above, then to this side. So that is where I'm going to mark. So this is it. 5 up, then 1 to the right. That's 5 over 1. That's 5 over 1. 5 up, that's 1. This is 2. This is 2. That's 5 up, then 1 to the right. Because it's 5 over 1. That's my slope is 5 over 1. That's rise, run. So then I will put my my line along the 2 points. So let's put our line along the 2. So this is, your line is going to cut across that 2 points. So I'll put my line. My line will walk through the 2 points. All right. Sorry for. So that is my line. You see? So my line will walk through that point. Yeah, I will make it thick. So Y is going to be thick line because, sorry, it's going to be broken line because it's less than or equals to. Sorry, it's going to be broken line. So let's pick our broken line. Why? Because it's less than or equals to. Can you see that? Sorry, it's greater than. Sorry, the line Y is greater than, strictly greater than. That is going to be broken line. Then which part to be shaded? Like I said, the part to be shaded depends on this. If it is greater than, look at this, greater than, then we shade the part that are greater than Y. That are greater than Y. That is all this part now, they are greater than this part. This part of Y, this Y part is greater than this part. So we're going to shade the part that are greater than. This is one method of doing it, since we have greater here. So this part is greater, this part is greater than this part. This part, you see that it's a positive, so this, the whole part here is greater than the whole part here, because we have Y greater than the other side here. So this part of Y is greater than this part. So this is one part of doing it, this is one way of doing it. Another way of doing it is this. You can use the origin. I think this is the one I always explain to students to use. Said you can use origin to test for the part to be shaded. So this is the origin. The origin is always at either side of the line. And at the origin here, the coefficient of 0, x and, the value of 0 and y, they are 0, 0. The value of x is equal to 0, y is also equal to 0 at origin. They can use origin to test for value. What you just need to do is this. You come to this equation and you see how you put your value, even if you have written it in this form. So I will just put my value of x here. So I will put 0 here, then greater than. Then I'll put 5 times 0, then minus 5. So at the end of the day, I have 0 is greater than, this is 0, this is minus 5. You see that 0 is greater than minus 5. If 0 is greater than minus 5, it means part of the region where I choose my what? Where I choose my origin, with this part where my origin belongs to, is the solution to the answer because it satisfies the equation. 0 is actually greater than minus 5. So it means this region, which I've also chosen here, I said this region is greater. So now the region where we test it with another, using the origin, is also the answer. So I now depend, they say unshaded region portion is required. If the unshaded region is required and this place is my solution, I'm not going to shade the region that is the solution. I'm going to shade the region that is not the solution. So if it is unshaded region that is required, I'm going to shade the region that is not what? That is not the answer. Exactly. So then to shade the region that is not the answer, then I will do it this way. This region is not the answer. All right. So this is the region that is not the solution. I'm going to shade it off. You see? So this region is not required. The region that is required is here. So this is actually the region that is required, which is a region that is actually greater than that. So I'm going to write my equation on it. Y minus 5x plus 5 is greater than 0. So you write it on that line. You write it on the line. And this is not our solution. The required solution is this place. So put your arrow on that part, this unshaded part. So that's how to do for the horizontal line. So let's use this one also. This one comprises of 3 parts, and I've explained some of these parts. And here we can use shaded region as our required solution, or we can use unshaded region as our required solution. It depends on the one we want to use. So let's go with this and see how we go about this. So it depends on the one you want to use. So let's, for example, unshaded region as my required solution. I like to use unshaded region as my required solution. So I like to use unshaded region so that it will be clear. Unshaded region. Unshaded region is our required solution. So let's use our unshaded region as our required solution. So that means any part that is not a solution, you shade it off. So now in this case, like I said before, we can derive this one in the form of another method. We can also use this in this case is this one is direct. X is greater than or equal to 0, y is greater than or equal to 0. This one is not difficult. Here, this line, we can also use intercept method. Said when we want to see when s is equal to 0, and that one will give us 2 coordinate points. So when s is equal to 0, say when s is equal to 0, what is going to be the value of y? When s is equal to 0 here, so this is another method. When s is equal to 0, what is going to be the value of y? So when s is equal to 0 here, then this place has become 0. So I have 2y will be equals to minus 4. That means this one will move to the other side. So y will be equals to minus 4 divided by 2, which is equals to minus 2. So the coordinates that we get there is 0, minus 2. This one. Then I also do when y is equal to 0. This is intercept method. So when y is equal to 0, when I put y is equal to 0 here, this 2 times 0. So it is only this one, the whole of this one becomes 0. Then it is only this one that will be useful. So when y is equal to 0, I have 2 of 0 plus x will be equals to minus 4. So here only x now will be equals to minus 4. So in this case, I have minus 4, 0. These 2 coordinates is what I'm going to use to plot my graph. It's enough for me to plot my graph. This is also very fast method to quickly determine which point that will give you the graph. If you don't know how to use, if you cannot rewrite this one in a standard, in a standard standard equation, linear equation form, which is of y is equals to mx plus c. You can write it in this form, and you see you can get your gradient and get your intercept like the way I did it in the first something. I'm going to be interchanging it like that so that whichever method that you like to be solution for you. So now, if you use this method, I can easily plot my graph. For the first one, s is greater than or equals to 0. Let's plot our graph now. S is greater than or equal to 0. So you pick a line where let's pick our line. S is greater than or equal to 0 is going to be vertical line. That means along y-axis, because that is where, so along y-axis. And greater than or equals to, is greater than or equals to is going to be thick line. Right? It's going to be thick line along y-axis. Can you see? It's going to be thick line. Can make it thicker. Can make it thicker here. That line thicker. Right? It's not only to be thicker. So this is our line for this one, for s greater than or equal to 0. And since I said which part on shaded region, s is greater than part. This part is greater. The whole of this part is greater. And this part is less than 0. It's less than 0. Part of x. This part of x. This is a value of x. This part of x, this region of x is greater. This part is less. So if this part is greater, this is the part I need. That is greater because we need the part that is greater. But the part that is less, we don't need it. I'm going to shade it off. Because we said on shaded region is our required solution. That's what I'm using. So you can see some video that we say that we'll be using shaded region. So if you're using shaded region, that means there's going to be intersection of shaded color, then to pick your region. But I don't want that. I want my region that I will be visiting to be clear, to be unshaded. So that means the shaded region is not required. I don't need it. I'm going to get the shaded region shade off. Let me shade them off. So let's pick our something like this. Let's go this way. Okay. Let's go this way. Okay. Let's go this way. Okay. Nice one. It means here, shade it off. That's make it transparent. This is the region I don't need. If I like, I can make it here. I can make it another color. Maybe make it using another color, maybe gray color, right? So this is the color. I have shaded it off. I don't need this part. This is the part that I need for this first one. The second one is y is less than equal to 0. Y is less than equal to 0 is y is x-axis. Y is greater than, don't think this y is x-axis. Anything along x-axis, that's where y is equal to 0. So I'm going to put a line on x-axis. So let's get our line. So we are using the line is here. So let's put the line on the x-axis. And here, let's, since because it's greater than, it's less than or equal, that is going to be thick line. So let's just make it thicker. We might change the color of that line. Okay, the color. Let's use this color. So to show the difference in the, okay, this is the second line, which is for this one. Y is less than or equal to 0. But which region? We need the part that is less than. This is the part that we need. This is the part that is less than. All this part is less than along that line here. But we don't need the part that is greater. We don't need this part. The part that is greater that we don't need, we're going to shade it off. So to shade it off, we pick our color. Let's pick our color. Let's pick our, okay. 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 All right. So with this, I don't need that part. I don't need it. So let's make it transparent so that at least you can see the part we don't need. If I like, I can make it pick color for it. Okay, make it another color that at least that we make it another color. So we don't need that part. Let me make this. Okay. Now we don't need this part. We don't need this part. So, and the last part, you see, this is the part now that's the intersection that's clear now that we need. Now, but we're still going to cut out of it with this one. Now here we can now use our coordinate point here to get this for this line. For this line to get the coordinate point, so we use the coordinate point here to get our, so 0 minus 2. 0 minus 2. Minus 2 is here. This is the part that is minus 2. When s is equal to 0, y is minus 2. This is the part. When s is equal to minus 4, y is equal to 0. So this is minus 4. This is minus 4 here. So we use this part, and this part, this part, and this part. So this is the two line. This is the two parts that our line we cut across. So let's see how we draw, or let's draw our line along that part. So with this, you can said our line is cutting across that part. Let's see. Okay. So don't mind me. So you see how our line should be. Just want you to cut across the 2 points. Since also is greater than or equals to, it's going to be thick line. So it's going to be, both of them are going to be thick line. So it's going to be thick line. So it's cutting across the whole graph. So this is what we have. Okay. So then which part to be shaded? Which part to be shaded? So is it above or below? I said in that case, you draw it. You can test using coordinate point. Look at this, our coordinate point here. You can test that point using our origin. Our origin to test the region. So you see that our origin is here. It's above the line. Look at this, our origin. So at that origin, x is equal to 0, y is also equal to 0. And the region is above the line. Is it going to satisfy the inequality? Satisfy the inequality that we have? So if you put it here, you can see that to satisfy, how can it satisfy this inequality? Let me clean this part. So can you satisfy this inequality? So let's pick the point and test. So here we put 2 into 0 plus 0, that is plus 4, is greater than or equal to 0. So the whole of this 0 here is going to be what? 4 is greater than or equal to 0. 4 is actually greater than or equal to 0. So it satisfies. This point where I pick my value actually satisfies the inequality. If it satisfies this inequality, it means this is the region that satisfies. That should be my answer, because this region satisfies it. When I pick a point here above the region and I put it inside my sum, it satisfies the inequality. Now this region did not satisfy my inequality, so this is the region I will shade off. I'm going to shade this region off. So I will draw a line, I'm going to shade this region off. Right, so that's the region. So it's going to be shaded off. See, that region is going to be shaded off. So now you can see the clear part now is this. This is the part that will be my solution. The part that will be my solution now will be here, this unshaded region. This part that is not shaded at all is our required solution. So this region is the region that we actually need our required solution, and it's from here. See the corner. So when we are doing optimization of numbers, or optimization of cost or profit, so this is the region that we consider to make a decision. Can you see? This is the region that we consider to make a decision anytime we are doing optimization. This is the region. You can pick at any point here. It's either, it depends on the model that you want to do, whether you are using it to minimize cost or you want to use it to maximize your profit. So this is the region where you pick, and any region here, you can plug it into your model and see whether you will get the one that give you the maximum. You can use it to maximize your profit. The one that give you the minimum, you can use it to minimize your cost. So that means it depends on the model you are using it for. Whether you are using it to, so that's how. So this will be the region that will be useful in our linear programming. If it is a real life, you are using it for a real life. So that is for that. Let's go for one more question. Draw the inequality graph of this. The graph of this. So, and unshaded region is our required solution. So we are using unshaded region. Unshaded region is our required solution. So our required solution. So this is how the question will come. So then we're using unshaded region as our required solution, and this is what you will see. So just to make it uniform. So unshaded region is our required solution, and in this case, we can put our graph. Let's put our graph and see how we can plot the graph and show the region that is our required solution. The graph is, so we have two linear graph here. Let's say three linear graph. One is direct. So the first one that is direct, so we don't need to work on that one. So let's work on the first one. So like I said before, when you have a graph of this form, you can write it in a standard form. If you want to pick, I think you may not, if you want to write this one in a standard form, you can write it in a standard form. and write it in the standard form of this. Maybe I will do one like that. I will do the other one, the other form. So let's, for example, this one, 3. So let me write this one in the standard form. Let's say y, 3x minus 2y plus 6 is greater than or equal to 0. This is what we have. Then if I want to write this one in standard form, I can write it as minus 2y, right? So I want the x to be there. Then I will put my greater than or equality sign. Then here, this 3x is crossing the other side, becoming minus 3x, right? So this, when it's crossing inequality sign to the other side, because I've written my inequality symbol. So with that, it's going to cross it. It's becoming minus 3x. Then minus 6. Minus 6 is also crossing. So this is what I have. Then I'm dividing both sides by a negative number, or this every term here by a negative number. If I'm dividing by a negative number, you know what happened. So minus 2y by a negative number, minus 2. The inequality operation will reverse. Then this one will be minus 3x minus 2. Then this one will be minus 6 divided by minus 2. So what I will get is y is less than equals to, here will be 3 over 2x. Then this one will be plus 3. So this is what I will arrive at. So this is one method that you can use. And from here, my slope, which is m that we are going to use, is going to be minus 3. Sorry, it's going to be 3. So it's positive. It's going to be 3 over 2. If you compare it with the standard slope, that's c now, is going to be what? The intercept is going to be 3. So with this is, so c is going to be 3. So with this is one method to plot your graph. Another method to plot your graph, let me use it for the second one. 5y, this is the intercept method, plus 6x less than equals to 30. You can use the one that's convenient for you. So you say when s is equals to 0, when s is equals to 0, what happened to y? If I put s at 0 here, automatically the whole of this place becomes 0. So what I have left there is, well, 5y is equals to 30. So just put equality sign at that point. Y is going to be 30 divided by 5. So it's going to give me 6. Now the coordinate at that point will be what? 0, 6. So this is the coordinate that we have for that point. And this is the coordinate is the important thing that you need there. Then you also do for when y is equal to 0 now. So when y is equal to 0, the whole of this place is equal to 0. When we put y is equal to 0 here, the whole of this one is equal to 0. So what will be left will be 6x is equals to 30. Put equality sign at that time. When you are testing for this, something like that, use equality sign this. So s is going to be 5. So the coordinate that you need to be 5, 0. This is the two coordinates that you need when you are using this method to get your graph done. With these two, I can plot my graph now. And so I use this method. If you write it in this method, you can plot your graph. If you write it in this method, you can plot your graph. I am showing the two so that you pick the one that is best used for you, so that to be easy. So y is greater than or equal to 0. Y is greater than or equal to 0, or I will go to, let's pick, I'll draw our line. So for y is greater than or equal to 0, y is along x-axis. This is x-axis. X-axis is for y. So I will just draw. What am I doing? Okay. So we are drawing our line. So this is the line. The line will be any line along the x-axis. X-axis is because it's equal to 0. Sorry, y-axis. So let's make it a thick line. Let's make it thick line. Why are we making it thick line? Because it's greater than or equals to. Greater than or equals to. Everything is greater than or equals to. That means it's going to be thick line. So you can make it thicker. To make it thicker, you just increase it here. Just increase it here. And to do that, then we want to shade the region that we need, the region that we don't need. And remember, I said unshaded region is our required solution. I like to use unshaded region so that to be clear, so that you will not be shading. I don't want intersection of line of a color. So I want something that will be clear, so that we cut the part that we don't need with what? With color, we shade it off. Unshaded region is required. That means if I have y is greater than or equal to 0, the part that is y greater than or equal to 0 is up. This is the part that's greater than 0. Here is 0. This line is 0. This part is lower than 0, is less than 0. The part up here is greater than 0. And that is the part I will not shade. I will not shade that part. I will shade the part that is less than 0. So to do that, so we will pick let's pick our shading color. So let's pick our shading color and shade it off. All right. Let me, yes. Thank you. So this part is not, we don't need it. You can use a beautiful color for that. So we don't need this part. So this part now, we don't need it because they are the part that is less than. So that is the part that is less than. We don't need the part that is less than. This part is less than. Y is less than equals to 0. We don't need the part that is less than. So we need the part that is greater than. That's the part up. And our line here is where Y is equals to 0. This line is where Y is equals to 0. So this region above is where Y is greater than equal to 0. So although this line is part of our solution, so we can put it as Y as greater than equals to 0, right? Because the line is part of our solution. So, and then to draw the second one, which I've highlighted here using one method, I said this method you can use, you can write the answer in a standard form, in the standard form of linear equation, Y is equals to mx plus c. This is what I've written. So when I compare this one to this one now, you can see that this. So this is Y, this is equality sign, I'm putting it as inequality now. So here, if I compare this one with this one, m is 3 over 2. If I compare this one with this one, my intercept is what? C, which is 3 plus 3. So in this one, you can use this one. And I said that if with your m, the slope, if you have a slope m 3 over 4, the upper one is what you call rise. The down one is what you call run. And the rise is, for the rise is like this, has two parts. The rise has two parts, which is the up and down. Up and down mean the positive side. Then the run has this side, horizontal, which is, this one is positive, here is negative. But for intercept is only 1 point. It's very easy to draw. Now, we want to do that using this method now. So the first thing you indicate is your intercept. What is my intercept if I want to draw this line now of the first one? I want to use this method now since I've written it in form of, in an equation of a straight line. So where is my 3? This is place where is my 3? My 3 is somewhere here. This is the part where I have my 3. This is my 3. And the 3, from 3, I'm going to what? I have 3 over 2 as my slope. That means up. Since it's a positive number, that means it is up. 3 up. 3 up we mean here. 3 up. From here, this is 1. This is 3. This is 1, 2, 3. Up. Then run 2 to the positive side. It's going to be good to go to the right. So it's going to be here. Run up here. So I'm not going to shade this part. I'm not supposed to shade this part. So this is run. This is rise, run. So this is the part where my line will cut across. So my line is going to move this way. So my line will cut, we go along this line, along. Sorry, let me adjust. Oh, God. Okay. Okay. Well, we extend it. Okay. Okay. All right. Can I extend it? All right. It must cut the two parts. All right. Okay, I think it's okay now. So, and Y is going to be thick line. Let's make it thicker. All right, I have this. So which part to be shaded? Which part to be shaded? Now, like I said the part to be shaded depends after you have written it in this form. You see that we have legs. Y is less than. The part that is less than mean is here. This less than. This less than. This is Y less than. This Y greater than. Up here is Y greater than. Down here is Y. After you have written it here, whatever the sign that you have here, after it has written in standard form, you only use it for standard. It must be written in standard form before you make a decision like that. If you have not written in standard form like this, you won't know where, because here you can see that it's greater than here before. But now when we have written it in the standard form, this is what we have. It's less than now. So the part that is less than is this region. The part that is greater than is this region. So we need the part that is less than. This is the part that is less than that we need. The part that is greater than, we don't need it. This is one point of determining it. Another point of determining it is what? Is to use origin. So you can use the origin here like this to determine it. At origin, x is equal to 0, y is also equal to 0. So you can plug in our origin here and determine what's going to be our answer. So if I put it here, either in this one or in this one. So we say 3 into 0 minus 2 into 0 plus 6 is greater than 0. So finally, you're going to get 6 greater than equals to 0. 6 is actually greater than equal to 0. You can see that the part where I pick as my origin, which is this part, it's actually the answer because it satisfies the equation. If it satisfies the equation, that means this region where I pick my answer is the solution, right? Is the solution, this region. The whole of this place below the line is region. So this one is not the answer. That's why I say we should shade it off at this thing. That's what we use here. The region that is less than this, less than, that means this region that is the answer. And when we use the other method, it satisfied it. This region is still the answer. So this region is not the answer. So the region that is not the answer, we're going to shade it off. So let's shade it off. So to shade it off, let's do it this way. All right. All right. All right. We can change the color. All right. Let's use this color. So can you see? So this is intersection, but we don't need the shaded part. So we can see that our answer is molding. This unshaded part is the region we are getting into. See, okay, let's go to the second line. Let's plot this second line to see the part that will still be cut off. So, and at this one, and you have to write on it, write on this, write your equation on this line. This is the equation, 3x minus 2y plus 6 is greater than or equals to 0. So you have to write it on the line to show the line that belongs to that, the equation that the line that belongs to the equation. So let's also do for the second equation, which is this 5y plus 6x is less than or equals to 30. And this one, I use another method. I use intercept method here. Intercept method is also very simple. You use the coordinate. Now you go to your coordinate. At x is equal to 0, y is equal to 6. Y is 6 here. 6. This is my first point. Can you see? This is my first point here. Y is equal to 6 here. So you see that this is my y is equal to 6. Very clear. Y is equal to 6 there. Then the second one, at s is equal to 5, y is equal to 0. S is equal to 5. S is equal to 5 here, in between 4 and 6 here. Here. So with this, I'm going to draw a line. I will draw a line across these two, or along these 2 points. Along these 2 points. Because a line can always be drawn with at least 2 points. So then to draw line, so let me pick a line segment. So let's join the line segment with the 2 points. All right, so let's extend it. Okay. So let's extend it up. Okay. So you make it thicker. So make it a thick line so that it will be visible. All right, this 2 line, this, and it's going to be thick line. Why? Because it's less than or greater than. There is equality sign there. So line is also part of the solution. Now the next thing is which region to be shaded. Since we did not write this one in intercept method, using a standard equation of a line, we did not write this one in standard form equation of a line. The only test we can use here now is to use our origin. So we can use our origin to test for this. Let's use our origin to test for this one. So the origin is here. And at origin, we have 0, 0 as usual. So, and the origin, when you consider that line, the origin is below that line. Look at the origin is below the line. And I'm picking the point where the origin is. And I'm plugging into our equation to see, does it satisfy the equation? So this one, give me 5 into 0 plus 6 into 0 less than equals to 30. So here, when I put it, this one becomes 0 plus 0 is less than equals to 30. So 0 is actually less than 30. So if 0 is less than 30, it means this portion where I pick my origin satisfied the equation. It satisfied it, right? Its answer is correct, right? 0 is satisfied. When I pick the point, and the point is below this. So that means this above the line, any point I pick there will not satisfy. Which will not satisfy. You can test for it. It will not satisfy. So it will not. That means any point I pick above it will not satisfy. Any point I pick below here will satisfy because I'm using one test and it has satisfied it. So the above will not satisfy it. So I'm going to shade that above off. And to shade the above off, so we also use our, we also pick our line, pick our shading. So let's shade it off. Let me pick the point here. Let me pick it. That's the point that did not satisfy my equation. I'm shading it off. I'm shading it off. Let's see. Can you see? So this part did not satisfy so I'm shading it off. right? Building something. So this part did not satisfy the equation. And like I said, you can use any beautiful color to shade it off. To You can see, you can use any color that you like. We don't need that point. We don't need it. Okay. All right. So we don't actually need the point. So that point, we don't need it. So our equation, remember to write your equation on the line. Remember, in the exam, you have to write the equation on the line so that to put the examiner on a spot line so that you will not be looking for which equation do you write here, which what this line represents. So you have to write it. It's very important to remember to write your equation along the line that you plot. So I have achieved the three line now, which is this one, this one, this one. I've drawn the three line, and I've put my equation along the line. This is y is greater than or equal to 0. This one is for this one, this one is for this one. And you can see that at the whole of the point, I have 3 points where the line intersect. Or let's say, see, I have here, then here, this another intersect point where the line intersected. Look at this. Look at this. Where the line intersected. I have 3 points. These 3 points, they are the 3 points we can use for optimization. We have other points. We have other points in between. Test all of them. Test all of them. They are very essential at any point that intersect line. So all the point here, look at this point, can be used for optimization. It can be used for optimization in linear programming. So, and you can use it to maximize profit. It depends on your model whether to maximize profit. Let's, for example, you are given a model that z is equals to 3x plus 5 plus 5y. And this is your model. And at this region here, we have a coordinate. This coordinate, read the coordinate from here. What is the coordinate of this one? What is the coordinate of x-axis? You put it here. What is the coordinate of this point? What is the coordinate of x? And what is the coordinate of y? You put it here. What is the coordinate of this one? What is the coordinate of x? What is the coordinate of this one? You put it here. So I'm just putting it here since we do not have a model. Then you plug it here. The one that gives you the maximum value will help you to improve your profit. If it is profit, you are using the model to do. The one that gives you the minimum will give you the minimum cost for your production. Maybe if it is what you are using something to make a decision where you will spend less something and still achieve maximum profit. So it depends on the model that you have. So this is what this one is used for, and it's very important you know this. That's that. Then we still have other, and we still go for one more graph. Still go for one more graph. Let's go for one.